Example 4. In example 3, each night's outcome is a result of a chance experiment rolling our four-sided die. Thus, there is a probability associated with each night's outcome. By multiplying the probabilities of the outcomes in each stage, you can obtain the probability for each branch of the tree. In this case, you can figure out the probability for each of our 8 outcomes. And just as a reminder, for this family, a card game will be played if a die lands showing a value of 1, and a board game will be played if a die lands showing the value of 2, 3, or 4. So this makes the probability of a board game on any given night 0.75. So let's use our tree diagram to look at some probabilities for the outcomes over the 3 days. So they have set up our tree diagram for us for a Monday, Tuesday, and Wednesday. Let's look at our first question. It says probabilities for 2 of the 8 outcomes are shown. Calculate the approximate probabilities for the remaining 6 outcomes. All right, I'm going to try to zoom in here just a little bit, try to clear up this table. All right. So we're going to work through here and add in all of these probabilities. You could just list these out on your paper as well. All right, so we have 0.75, 0.75, 0.75, so we've multiplied all 3 of those together, and they've given us a probability of about 42%. All right, so for board game, card game, so we've got 0.75 times 0.75, and then our card game is 0.25. And when we multiply that out, we get 0.140625. All right, so board game, card game, board game, 0.75 times 0.25 times 0.75, which would be the same answer as above because we have 2.75s and 1.25. And with multiplication, it's commutative. Oh, scoot that over so you can see the numbers, I'm sorry. Okay, so we're going to do board game, card game, 0.75. Card game is 25%, and then another card game. When we multiply those together, we get 0.046875. Okay, we're going to do card game, board game, 0.25, 0.75, 0.75. So that again is our 0.140625. The next one is completed for us. We're going to go down to our card game, board game. 0.25, 0.25, and 0.75. When we multiply those, we get 0.046875. And then our last one, card game, 0.25, 0.25, 0.25. And when we multiply, we get 0.015625. Okay, let's zoom back out a little bit here. Okay, our next question says, what is the probability that there will be exactly 2 nights of board games over the 3 nights? So we're going to go through our list and list out the ones that are exactly 2 nights of board games. Doesn't matter which order. This one has 3. This one has 2. So B, B, C. We've got another one, B, C, B. This only has 1 board game. This one has 2 board games. C, B, B. This only has 1, this only has 1, and that has 0. So we have 3 different outcomes, but we're looking for their probabilities. So next to these, I'm going to list out what those probabilities were. So that's taking them from right here where we solved and found those probabilities. So for each one of those nights, it's 0.140625. So we're going to list those out on all 3. Now to total these up, because we're talking about all 3 of them, we can multiply times 3. And when we multiply, we get that that is equal to 0.421875. Okay. And our last question, what is the probability that the family will play at least one night of card games? So if we look at our outcome list, every night has at least one card game except for this very top one, which was board game, board game, board game. So again, if we had all of these probabilities added together, that would be 100% of our probability. So we could take 100 and subtract out this probability of board game, board game, board game. Okay, so it's all outcomes except board game, board game, board game. So we're going to do 1 minus 0.421875. And that gives us a probability of 0.578125.